Vermont Bike Solutions, in partnership with Amtrak, has a wall-mounted bike rack on passenger trains. The bike rack currently available is unable to properly support bicycles of tire widths larger than 3 inches. The goal they set for our team is to design, build, and prototype an adjustable wall-mounted bike rack that can accommodate for this range of tire widths. Together we came up with 6 possible designs of a bicycle rack that would meet our client's objective. The guided clamp, the wing nut design, the threaded nut on hook, the spring system, V-shaped plate, and the V-shaped plate combined with the adjustable hook. The guided clamp design uses a pipe clamp with a hook on it. The clamp is placed on a horizontal bar and can slide back and forth to adjust for different tire widths. The wing nut design uses a wing nut attached to a disc on a horizontal bar of the bike rack such that the disc can move closer or further away from the bicycle tire. The threaded nut on hook design uses a horizontal hook and a nut such that the hook arm rotates inward and outward, allowing adjustability for bike tires. The spring system design is similar to the wing nut design, except that it will have a spring system on both sides of the tire to hold it in place. The V-shaped plate design enlarges the hook and changes the geometry of the back plate such that the bicycle tires are funneled into place. The V-shaped plate combined with the adjustable hook design is the same as the V-shaped plate, but it is added by one of the adjustable hook design.
The design that we chose to work with is the guided clamp design because it best fits with our client's objectives, and it is simple enough to manufacture. Here is the SolidWorks drawing of our design as it rotates around for better viewing. And here we can see the transformation of the wall-mounted bike rack on our test bench as it starts from our client's minimum, transitions to the adjustable bike rack that we designed in SolidWorks, and 3D printed using the University of Vermont's fabrication lab. And then our final adjustable wall-mounted bike rack, machined by the instrumentation and model facility, welded by Floyd Vilmont, and completed by our team. We tested the strain experienced in both the minimum and our design for comparison.
Alright, so basically right now we are trying to see the stress levels on the bars. So we have a strain gauge attached to the design, and we are trying to see at various distances on the horizontal bar what the strain would be on one side of the beam. So right now I am measuring the bike location at different distance on the horizontal bar, and we're reading up the strain data so that way we can plot graphs to see how the strain changes or at the stress changes on different locations on the bar.
We also tested the motions and vibrations that both bicycles and the bike rack would be experiencing on an Amtrak train by using an Arduino Uno and an accelerometer attached to the wall of the train. We then repeated the test in a U-Haul truck with an additional accelerometer attached to a bike tire mounted onto our design, and found that the bicycle experienced less acceleration than the bike rack did, which means that our bike rack sufficiently secured the bicycle in place.
The most important objective set by our client is that the bike rack is adjustable and can support bicycle tire widths larger than 3 inches. Here we borrowed a fat bicycle from a fellow student and lifted it onto our bike rack attached to the test bench, fit the tire and spokes through the guided clamp, and adjusted it to the fat tire. In the last stages of our design, we included a quick release to fasten the clamp into place in order to make the design more user-friendly. As can be seen, the old minimum design is far thinner than the fat bike of 4.6 inches. The incorporation of the adjustable wall-mounted bike rack will encourage all cyclist commuters to use mass transit systems, reducing our carbon footprint. Additionally, it will attract non-cyclists to begin using bicycle transportation for their commutes.